From the RSNA, this is the Radiology Artificial Intelligence Podcast. My name is Paul Gee, and I'm a radiologist at the University of Maryland and co-host of the podcast.
And my name is Tejani, and I'm a radiology resident at the University of Texas Southwestern Medical Center and co-host of the podcast. Each month, we dive into the hottest topics in radiology AI and talk with leading experts, thought leaders, and movers and shakers in the field. It's time for the Radiology AI Podcast. You may have heard of or already used TotalSegmentator. Now, let's hear more from the creator on their team's experiences and any updates since publication of their work.
Jakob Wasserthal is a research scientist at the University Hospital Basel. After studying computer science and co-founding a successful software startup, he did his PhD in medical image analysis, focusing on brain connectivity and diffusion MRI. He is the creator of TotalSegmentator, an open source toolkit which enables automatic segmentation of all major anatomical structures and CT images, and is being used by thousands of researchers, developers, and doctors worldwide.
Jakob, thank you for joining us for this episode of the Radiology AI Podcast on TotalSegmentator. Oh my gosh, what a gift this tool has been to our field. I think that all of us can agree that this is a very exciting development, not just for radiology, but for AI. And thank you to you and to your team for working on this, for very succinctly and clearly presenting it in your latest publication in the journal as well.
Yeah, thanks for having me.
So let's go ahead and get started. For those of us who may not have read the paper, or may not have heard about it, can you tell us about what TotalSegmentator is? What is its intended use for those of us who haven't used it? And then if you could also tell us what's covered in the latest or that first version of the tool as well.
Sure, yeah. So TotalSegmentator is like this open source tool which we built, where you can segment basically all major anatomical structures in any CT image. And I would say it originated over the time. So I was working on different projects, research projects regarding radiological images. And so we did some projects for different organs. And at one point I thought, okay, can we combine that into one big model? And then we add some more models which are open source, and we add some more stuff that's missing. And then in the end, that's basically the origin of the TotalSegmentator. And then I thought, oh, let's make a nice big data set for training this and really make it work on any kind of images. Because it's also often the case you have one model which was, trained for the liver, but then in your one project you have the data set with abdomen images of the liver, and then in your next project you want to reuse it, but then that's whole body images, and your model doesn't work anymore properly because they're different kind of images. And so really my focus was build it in a way that it's just working for any kind of CT images and you don't have to care. And that's why we created this big training data sets, which is basically a random sample from our clinical routine. I really randomly picked images from our PACS system and annotated those. And there are also some ugly ones in there. And then typically in other projects, you would go for, I exclude this images and I exclude those images because they don't look so nice and there are artifacts in there and problems and motion. And here you really said, no, we don't exclude anything. Just segment it as good as possible and do a best guess if it's hard to tell. And I think the result is now this tool, which works really nicely. And I also put quite a bit of effort into making it really easy to use. So that's basically the result. So anybody can use it. It's easy to use. It really works on any kind of CT image. And that's the TotalSegmentator.
Yeah, so TotalSegmentator, I got to say, for my group, this has really, truly been a gift, as Ali has said, and as our journal had a really nice editorial about it. I am curious, though, were there any differences in performance across subgroups, whether it's by anatomy and organ type, or maybe across different demographics during initial analysis? And maybe another way to put it is the tool generalizable?
So I didn't do any in detail subgroup analysis. So I figured out, I have this random subset, and my test set is going to be another random subset of our data set. And so it's kind of representative of your typical clinical routine. And so the performance which we report is basically the average you would expect to get on a clinical sample. So yeah, we didn't do like extensive subgroup analysis, but of course we noticed different kinds of like problems which might occur. And yeah, overall it works really well. But then there are some errors which occur sometimes, like mixing neighboring vertebrae or ribs. So for the model, it's hard to distinguish if it's, I don't know, vertebrae L4 or L5 sometimes. And it also depends, of course, what kind of image do you have. If it's not don't have the whole abdomen in the image, it's also for human difficult to tell where am I actually and which one is it. So that's an error occurring more regularly. And then, of course, if you are on images without contrast agent, some structures are also very difficult to see, like the iliac arteries, for example, really difficult to see without contrast agent. And then also the model is starting to struggle. But that's also in general, we trained the model on images with and without contrast agent. So it really works quite well for both, except for some of those structures which you really can't see without contrast agent. Yeah, and then we really were quite also astonished to see that it works actually quite well on a lot of pathologies. So we have some of those in our paper, like broken bones and, like, say, people with splenectomy. So you got your spleen removed, or you got a kidney transplant. And then it's also interesting to see, like, you have your left and right kidney, and when you get a transplant kidney, I didn't know that actually beforehand. Often they don't remove your old one, but the old one just getting really small and atrophic, and they insert a new one. So in the end, you actually have three kidneys. And the model really then also detects three kidneys, which I find, yeah, quite astonishing. I would have expected the model to be more confused about that, especially since our training data set maybe only contained 3 or 4 of those cases. So yeah, that's really nice. On the other hand, yeah, it's also failing on some pathologies, especially if they're really distorting the anatomy, like having major bleedings, for example. So we worked with one data set with a lot of bleedings, and we figured out that, yeah, there the model is struggling, but then most of the times if the model is struggling, the radiologist is also struggling. So then if you ask the radiologist to correct the segmentation, it's also difficult for him to tell where actually the border would be, like where exactly is the liver border if there's a major liver bleeding. So yeah, that's really, I guess, getting ambiguous for even for the human. And yeah, then we added some of those cases, or whenever we ran across some of those problems, we added some of those cases to our training data set. And now for our version 2 of the tool, we used this bigger data set where we tried to add those cases where it failed before. So hopefully it became a bit better now. So yeah, and coming back to your question about generalization. So from my experience, it really works on all the images I use it. And it's really nice to see other people who told me that it really worked. And I think I also got a lot of positive feedback from other people. And I have the feeling like one of the main reasons is that they do not expect it to work properly, because that's what you get some code from GitHub, you run it, and you're already used to it not working too well. It's nice in the paper, but typically it's not so nice on your data. And I have the feeling most of the people are really astonished that now it actually works as like in the paper. And so I got a lot of positive feedback from people telling me that they use it, that it works, and so on. So I have the feeling it really generalizes. And yeah, it's from people all over the world, from all continents. And so I really have the feeling it's generalizable. Yeah.
That's great to hear. I'm not surprised at all that the feedback isn't positive. Just even with personal experiences, it's very it makes me very happy to hear that. Let me just say it that way. What are some of the use cases? I'm curious that either the developers or researchers, anyone using this tool, have they told you what they're using it for, or if they intend to incorporate it in a larger model? What's the feel out there?
Um, yeah, I would say it's all different kind of things. So it's really thousands of people using it, and for basically, I would say anything where you wanna do some automatic processing of CT images, the total segmentator comes quite handy at one step in your pipeline. So either because at first you wanna just identify the region of interest you wanna crop your image to, um, or because I don't know, the segmentation of the vertebrae helps you to figure out where you are in the body, or to also crop your image. So yeah, so it's really a lot of different use cases. Um, yeah, it's it's hard to tell. So some I know they are looking at the volume of, let's say, the heart chambers, looking at how they are correlated to some risks. Um, yeah, other look at fractures in the vertebra, and so I guess it's all kind of things you can imagine.
Absolutely, no, that's absolutely great. So we talked a bit about how you and your team and others have had these insights, right, that kind of come to light after you start using the tool. Has that impacted any plans for a version two? Let me give you an example from our experiences. I think we tried looking into using it for like obstetric anatomy, so placenta, helping characterize the placenta, but that may not be covered in the first version. Are there other similar insights that either your team has had or others have told you in your team that you're planning to incorporate for future versions?
Yeah, there are actually quite a few people who ask if the total segmentator can segment certain things which are not part yet. And then, of course, those are new structures which I try to incorporate. And then it depended a little bit also on what we needed, what was easy to do, or whoever contacted me in a time where I was not too busy, so I could edit. And other people who contacted me when I was busy, then it just ended up at the bottom of my to-do list. So yeah, that's now for version two. I think yeah, most of the new classes were actually originated from either people asking me or ourselves needing that segmentation. Then also people, of course, reported a lot of, well, either bugs or let's say improvements for the software which they wanted. And so we also tried or that's also, I tried to build that into the software actually. Um, and then also a lot of people, of course, they tell you, oh, it's not working on my data. And then my first intuition is always, oh no, it's not working. But then typically it turns out it's just the data is not normal data. So quite often they normalize it to the range from 0 to 1, and it's not Hounsfield units anymore, and they wonder why it's not working. And then I see, okay, I know why it's not working now. So that's also a lot of feedback. So what's actually not really happening, people sending me cases where the images are a proper image and it just did not work because I don't know of some pathology. I guess there are those, or I myself have experienced some of those cases. But interestingly enough, people did not send those to me. Um, yeah, I'm not sure. Maybe people know that it's just a big pathology and they don't expect it to work too well then. Yeah, so that's kind of the feedback I got, and how I tried to incorporate it.
Well, Jacob, I gotta say, thank you for taking the time to respond to the feedback too. I think that's really generous of you. So thank you for. I know it can be busy, right? So it's really heartwarming to hear that you've been taking this feedback to heart, listening to what the users are saying, and really trying to help them, or help us rather, make the most of this tool.
Yeah, it's also nice to have the feedback, of course, or it's also a motivation to have this direct user feedback. So I like it being basically charge of the entire pipeline. So coming up with ideas, what I want to add, building the tool, And then also being in direct contact with some users and getting feedback, and then also being able to decide how do I wanna build the tool in the future or adapt it according to the user needs. But of course, sometimes it's also annoying to answer all the questions. But yeah, it's really satisfying that a lot of people use it. And for people to use it, it has to be usable and there has to be some support. So that's I'm happy to do that. Yeah, it's satisfying just to see many people using it. Yeah.
Yeah, so Jacob, I want to echo that I've been really happy with how it's performed. I think it's a tremendous gift to the community, and I think it's even more astounding that you continue to build on it, whether it's through, in a lot of ways, tech support, working with people trying to get it to work, but also updating it. So with that, I think we'll be respectful of your time. We've got a double header here, doing 2 podcast recordings in a row, and so I just want to maybe conclude by asking, how can readers get access to the model? Is it still on the GitHub? Should they refer to that as the official place, or is this going to be maybe somewhere else in the future?
Yeah, it's gonna keep on. It's on GitHub, and it's also gonna be there in the future. So that's the place to be, the place to go to. And yeah, and if you install it via pip. That's also gonna stay this way. The documentation is on GitHub. And yeah, we also have our data set, which is on Zenodo to download. And there I recently also added some links to a copy of the data set actually on Dropbox, because Zenodo can be quite slow, actually, I figured out. Well, that's also something that people told me, that take them a long time to download. And I figured out Zenodo is sometimes quite slow. And so I created another copy on Dropbox, which I think has a lot stronger servers. And now you can hopefully download it a lot faster.
Outstanding. Well, everyone, you heard it here first. GitHub's the place to be. So make sure you check out TotalSegmentator V2 now and all the updates that are to come. So Jacob, thanks again for joining us here on the Radiology Artificial Intelligence podcast. It's been an absolute pleasure.
Thank you. Yeah, thanks for having me. Great talking to you.
Definitely.
Thanks for joining us for this episode. You can read more about TotalSegmentator in Jakob and his team's publication in Radiology Artificial Intelligence.
Subscribe to the Radiology AI podcast for more discussion on content from the journal and other hot topics in our field.
We hope that you've enjoyed this episode of the Radiology Artificial Intelligence podcast. Shout out to Uriah Shemchisen for our podcast music and to the RSNA podcast staff.
Email us at podcasts@rsna.org anytime with questions, feedback, or suggestions.